The sun has fooled every generation that has ever looked at it. Every morning, it rises with the same brilliant light. Every evening, it disappears below the horizon. Nothing about it suggests that anything fundamental is changing. The records tell a different story. For more than 4 centuries, observers have watched small, dark markings appear on the sun, drift across its surface, disappear, and return again. At first, they seemed like isolated imperfections, but as one generation handed its observations to the next, those markings refused to behave like random blemishes. They kept coming back. That contradiction became impossible to ignore. If the sun is truly constant, why have observers spent more than 4 centuries measuring the same repeating change? By the end of this investigation, those tiny dark markings will no longer be the mystery. They will become the evidence. The first clue almost disappears into the sun itself. A modern telescope can capture the sun in extraordinary detail. On many days, its surface appears almost flawless. Perhaps a single dark mark interrupts the brilliant disk. Sometimes there are none at all. Looking at one image, there is little reason to suspect that the star is undergoing any remarkable transformation. One image hides the pattern. Place thousands of those observations side by side, and an entirely different picture begins to emerge. The dark markings increase in number, spread across the sun, gradually fade away, and then return once more. The sequence repeats. Not once. Not twice. Again and again. Long before spacecraft watched the sun from orbit, astronomers were already recording the same pattern by hand. Early observations from the 17th century were followed by centuries of daily measurements. Independent observatories, separated by time, location, and technology, all documented the same recurring rhythm. The number of sunspots rises. It reaches a peak. Then the sun grows quiet again, until the cycle returns. What first looked like scattered imperfections becomes a measurable pattern. Modern observations confirm exactly what the historical records revealed. Across more than 4 centuries of continuous measurements, the same cycle appears over and over again. The sun is not as visually constant as it seems. The investigation had quietly changed. The records had already settled the first question. The sun changes. Now, only one remained. What keeps making it happen? One possibility is that these markings are nothing more than stains. After all, they appear darker than everything around them. They interrupt an otherwise brilliant surface. Perhaps they are simply cooler patches, temporary scars with no deeper meaning. For decades, that explanation remained plausible. A dark spot did not automatically imply a hidden process. It only proved that one small region looked different from the rest of the sun. The investigation could go no further by looking at the surface alone. Everything changed when astronomers stopped asking what sunspots looked like. They began asking what the light coming from them could reveal. In the early 20th century, a solar observatory examined sunlight passing through one of these dark regions with a spectrograph. Instead of producing the same clean pattern seen across the rest of the sun, several of the spectral lines had split apart. That effect was already known from laboratory experiments. Strong magnetic fields force certain spectral lines to divide into multiple components. The same signature had now appeared inside a sunspot. The investigation changed immediately. The darkness was no longer the defining feature. The magnetic field was... For the first time, the sun's invisible structure had left direct physical evidence that instruments could measure. More than a century later, modern spacecraft returned to the same question with far more powerful instruments. Instead of measuring light from a single location, They mapped magnetic fields across the entire visible face of the sun. The result was unmistakable. Every major sunspot aligned with concentrated magnetic regions. Even more revealing, they rarely appeared alone. They emerged in pairs. One region carried one magnetic polarity. The other carried the opposite. What had looked like isolated dark marks in ordinary photographs suddenly revealed an invisible pattern stretching beneath the surface. The recurring object had changed. Those tiny dark markings were no longer imperfections interrupting the sun. They had become windows into something hidden. The first mystery had been solved. Sunspots were not the cause. They were the evidence. Continue. But solving that question exposed a larger one. If these magnetic fields keep appearing in the same repeating rhythm, how do they become powerful enough to unleash the sun's most violent eruptions? Those paired magnetic regions do not remain still. Above them, the sun's atmosphere is filled with immense glowing arches that rise far beyond the visible surface. They appear and fade continuously, bending across active regions like enormous bridges suspended in space. At first glance, they look like streams of blazing gas. But the gas is not leading the motion. It is following it. The glowing plasma is trapped by invisible magnetic fields, forced to travel along their paths. The light reveals the route, not the structure itself. For the first time, the investigation extends beyond the sun's surface. The magnetic fields identified inside sunspots continue upward, shaping the atmosphere above them into vast, looping structures that can persist for days before slowly changing form. The magnetic field is still invisible. Its architecture is not. Time-lapse observations reveal something else. The loops do not remain fixed. They stretch. They twist. They crowd against one another. Hour after hour, the entire structure becomes more tangled. The atmosphere of the sun is not settling into balance. It is accumulating tension. The investigation changes again. The question is no longer whether magnetic fields exist. That evidence is already secure. Now the evidence suggests something more unsettling. The magnetic field is changing continuously, even after it reaches the surface. Eventually, some of those twisted loops can no longer maintain their original structure. When magnetic fields pointing in opposite directions are forced together, they rapidly reorganize into a simpler configuration. Scientists call this process magnetic reconnection. The magnetic field itself cannot be seen snapping into a new arrangement. Its consequences can. Within moments, an intense flash erupts from the same region. The surrounding plasma is suddenly accelerated, heated to extraordinary temperatures, and driven outward through the solar atmosphere. What appears to be a sudden explosion is actually the release of energy that had been building quietly within the magnetic field. The investigation has changed once more. Solar flares are not isolated bursts of violence. They are evidence that magnetic tension has reached its limit. Sometimes the reorganization ends there. Sometimes it does not. Spacecraft watching the sun from outside Earth's atmosphere have recorded something even larger. Entire clouds of magnetized plasma can be launched away from the sun, carrying billions of tons of solar material into space. These eruptions expand outward through the solar system, moving far beyond the region where they first began. The flare is only the flash. The eruption is the consequence. The recurring object has changed again. The same dark markings that first appeared as tiny imperfections on the sun's surface are now connected to immense magnetic structures reaching high above the star. They were never isolated features. They were the visible entrances to an invisible system, storing enormous amounts of energy. One question still refuses to disappear. If magnetic tension can build, release, and rebuild itself over and over again, why does the entire process grow stronger, then quieter, before repeating with such remarkable regularity? Individual flares can seem unpredictable. One active region erupts. Another remains quiet. One cycle produces extraordinary activity. The next is noticeably weaker. Viewed one event at a time, the sun appears to behave almost at random. But the long record tells a different story. When generations of observations are placed on a single timeline, the largest bursts of activity do not appear evenly scattered through history. They gather into distinct periods, separated by quieter years in between. The same rhythm first seen in sunspots appears again. Not just in where the sun changes, but in how violently it behaves. The investigation has changed. Solar flares and massive eruptions are no longer isolated events. They belong to something larger. The historical record reveals a repeating cycle. Every few years, the number of sunspots climbs. Solar eruptions become more frequent. The sun enters its most active phase. Then the activity gradually declines until the surface appears quiet once again. The pattern repeats. Again. And again. Scientists call the active phase solar maximum. The name describes what is observed. It does not explain why it happens. One measurement provided the next clue. Instead of counting how many sunspots appeared, researchers began plotting where they appeared. At the beginning of each cycle, most sunspots emerge far from the sun's equator. Year after year, new sunspots appear progressively closer to the middle of the solar disk. When every cycle is layered together, the pattern forms two sweeping wings that descend toward the equator. The result is so consistent that it has its own name. The butterfly diagram. The investigation changes again. The sun is not producing sunspots wherever it happens to please. The activity is migrating across the star in an organized way. The cycle has structure. It has direction. And it follows the same path again and again. One final observation completed the picture. The paired magnetic regions inside sunspots do not keep the same magnetic orientation forever. After one complete cycle, their polarity reverses. The leading magnetic pole becomes the trailing one. The pattern begins again. Only now the entire magnetic arrangement has flipped. The quiet sun at the beginning of a new cycle is not the same quiet sun that existed 11 years earlier. It only looks the same. The investigation had reached a different scale. Sunspots, magnetic fields, coronal loops, solar flares, massive eruptions. None of them are separate phenomena. Each is one visible stage of a single magnetic system that continuously rebuilds itself. Solar maximum is not an era when the sun suddenly becomes violent. It is the crest of a magnetic cycle that has been unfolding for years before the first major eruption becomes visible. The recurring object returns once more. The tiny dark markings that first seemed like insignificant blemishes have become the simplest way to watch an invisible magnetic engine reorganize an entire star. Only one question remains. When the sun grows quiet again, has the engine finally stopped? Or has the next cycle already begun? The sun grows quiet. The number of sunspots falls. The towering loops become less common. Powerful eruptions become increasingly rare. Once again, the solar disk begins to resemble the calm star that has greeted every human civilization throughout history. It is the same image that opened this investigation. But it no longer means the same thing. The investigation did not end with a quiet sun. It ended with a quiet sun carrying an entirely different magnetic structure than it possessed only one cycle before. The calm is real. The stillness is not. The global magnetic field has already reversed. A new cycle has already begun. Long before the next period of intense activity becomes visible, the hidden transformation is already underway. The investigation reaches beyond astronomy only because the evidence does. When the sun passes through its most active years, the effects are measured far beyond the star itself. Powerful eruptions can disturb Earth's magnetic environment, disrupt radio communication, interfere with satellites, and induce electrical currents in long transmission lines. During the geomagnetic storm of 1989, those currents contributed to the collapse of Quebec's power grid, leaving millions without electricity for hours. These are not separate events. They are downstream consequences of the same magnetic cycle reconstructed throughout this investigation. The historical records reveal that the sun changes. Spectral measurements prove those changes are magnetic. Modern observations showed magnetic fields storing energy above the surface. Solar flares and massive plasma eruptions revealed how that energy is released. Long-term cycle records demonstrated that the entire process rises, peaks, subsides, and begins again with remarkable regularity. Each discovery answered one question. Each answer became evidence for something larger. The recurring object returns one final time. A single dark marking crossing the face of the sun. 4 centuries ago, it looked like a small imperfection interrupting an otherwise perfect star. Today, it is something else entirely. It is visible evidence that an invisible magnetic system is rebuilding the sun in plain sight. The sun has not become more mysterious. Only our first impression of it has. The bright, quiet disk remains. Its magnetic heartbeat never stopped.